Okay. Now, quadratic function, you might be surprised, we do know quite a bit about them. They are second degree functions. What does that mean? Second degree. It has an exponent of 2, right? The biggest exponent is going to be 2. Good. It has a lot of real-world applications. These are actually important things, quadratic functions. The shape of cables on a bridge. So here I got the Golden Gate Bridge. That's kind of a quadratic shape there. Area is actually a quadratic because an area is like an x times a y. That's 2 variables. It's quadratic. Trajectories. What's a trajectory? What is that? Oh, if we fling you out of a cannon? What? Okay, so if we fling her out of a cannon, that's the path she's going to make. That's quadratic. That's an interesting example, and I'm getting that visual now. Okay, a falling object is quadratic. There's a lot of physical applications. Velocity. Orbital objects are quadratic. And of course, the most important one, that thing, look at that, the golden arches, they are quadratic. So we're going to learn a little bit more about them. Quadratics come from the conic sections. So if you have 2 ice cream cones and the points are touching, that's what these are supposed to be. And a section is just a cut. Just need to take a cut, slice through it. So when I slice through this way, you get a shape that looks like this. And these are the ones we're going to be looking at. Okay, so we're going to be looking at that. These are called parabolas. Next year in geometry, we're going to look at when you cut straight through and you get a circle. So you'll look at that in geometry. Now these things, if you go this way, you get kind of an oval shape. It's called an ellipse. And when you go kind of straight through, you're going to see this. We actually saw this a little bit. It's called hyperbola. Does anyone remember where we saw hyperbolas? Hyperbola. Yeah, that thing was class, right? Inverse variation. Excellent. That was a hyperbola. We saw a little of this. You see more of this in the class after algebra 2, usually pre-calculus. You'll see some of this and see some of this. So the conic sections, they have things that are the same, things that are a little bit different. So we're learning about our first one right here. Pretty cool stuff, the parabola. So here it is. So here are some of the pieces in a parabola. It is this shape here, almost like that cable on the bridge. It's kind of like this. In the middle, we have a line. And that's important. This thing is a line. And it's called the axis of symmetry. What's an axis? Yes.
It's the x-axis and the y-axis.
Yeah, so they're special lines. So an axis is just a line. These are sometimes called lines of symmetry because it means the same thing. What does that mean, symmetry? What is that?
Both sides of the same.
They look the same in kind of a reflective way. Yeah? Did you guys learn about transformations?
Yeah.
Remember that? Remember reflection?
Yeah.
So this piece is a reflection of that piece, which means if this were a piece of paper and I were to fold along the axis of symmetry, these points would all line up, right? And this would lie exactly right on top of that one. So the axis of symmetry is that fold line. That's what it is. It's a line, and I'm going to keep saying that. It's a line, it's a line, it's a line. Now it's a straight up and down line. How do we write equations of straight up and down lines? Yeah, do you remember? It is an undefined slope. How do we write that equation? Remember?
Like
What?
x is not equal to.
X equals. So x equals, remember what x equals 4 looks like?
Yeah.
That's this thing, right? Over here for 4. What's the one that goes this way? Y equals, right? So what's the equation of, say, this red line?
X
X equals 0. Yeah. So in this particular parabola, the axis of symmetry is x equals 0. Would I say the axis of symmetry is 0? No, 0 is just a number. It doesn't mean anything. X equals 0 tells me you have a line. So that's what that is. The vertex is this point here where it's kind of at right on the axis of symmetry, where if you were to fold, like look here it's falling, right? Going down, going down, going down, whoop! Going up, going up, going up. So the vertex is where it changes. We call a vertex a turning point. Because it turns. I like it when they make sense, right? That makes sense. Turning point. So you turn. Yeah.
Is the vertex always going to be when point is 0?
No. But Is it always going to be on the axis of symmetry?
Yeah.
Yes. So X, I love that question. What a great, great question. In this case it is. Can you picture parabola being somewhere else on the graph?
Yeah.
It can be. And so you can still have a vertex. So it doesn't necessarily have to be on 0, 0. You guys are, these are great questions. Let me catch up. This is standard form. ax squared plus bx plus c. Where have we seen that before? Yeah, type 5, or maybe if we're lucky a type 3 if the a is in 1. But now it's a function that looks like this, right? We saw this when we did factoring. The parent function, which is why I'm so glad you asked that question, Ray. This is a picture of y equals x squared. We call that the parent function of all the quadratic functions for parabolas. Basically, one way to think about graphing parabolas is to think about transformations on the parent function. So it's like I take y equals x squared and I transform it somehow. Do you remember what some of our transformations were? What were some of the different kinds of transformations? Do you remember any of them? Do you remember?
Slide.
What else did we have?
Flip.
Reflection, slide, turn. Right, these were kind of the like fun names. This is called a translation. That's the big boy, big girl math name. Right? This is called a reflection. This is called a rotation. Now we don't do as much with the rotation with these, because what happens if you turn this on its side? That's a rotation, right? Is this still a function?
No.
So we're not going to be working with the ones that aren't functions. There's nothing wrong with having one on its side, but it's not a function. We're not kind of concerned with that for what we're doing. We're less concerned with the rotation. Now a flip. Think of this flipping this way. Can it flip that way? Sure. And it's still a parabola. It's still a quadratic. It's just flipped. So you take this parent function, you flip it. What about if it was up here? That's a slide. That's a translation. You take this parent function, you slide it. Or maybe you slide it down. Maybe you flip it and you slide it, right? Yes. Hey, that was his question. No, because I could be over here. Now y equals x squared. Yes. Parent function always starts here. But if I do a translation, maybe I slide it over this way. And now it's over here. So you take that parent function and you do different transformations on it. It is a way of thinking about how to graph these. Yeah, maybe upside down. Sure, that's called a flip. Right? Isn't that a flip? Absolutely. So when you see different parabolas, so if you see one that kind of looks like this, well, I basically started with that parent function. I flipped it and I split it. So it's a reflection and a translation. Or maybe I translated it and then I flipped it. So it's a different way of thinking about graphing when you get to these higher order functions. Yes? Y equals x squared is that's parabola. Right? Looks like some number. Okay. Vertex we just talked about, and the axis of symmetry. We talked about all these things. Yeah, to maximum minimum. I should mention that. When you look at these things, let me erase some of this stuff here. So the vertex, it is a turning point. Another name for this vertex is minimum. Why do you think it might be called minimum? Why do you think? Because why? It doesn't always have to be right there, but no matter where it is, I call this point the minimum. Why? Why do you think you do that? That's as low as it can go. And when I talk about it, the smallest point, I really mean its y value, right? The y values will never be less than 0. Think about when we talked about domain and range. Looking at this, what's the range? No? Where do you see values for y? Right, remember y is
Y.
Y greater than or equal to 0. Yeah.
right? It's not going to be the range. Now, domain, this way, is all real numbers, but my range is that way. Can I ever be less than 0? No. 0 is the minimum. And in this case, I am talking about that 0. If I was over here, and this was 0.5, -6, say, what's the minimum value? What's the range? y is bigger than -6. So that's my minimum value. Now let's say I flipped it. Looks like this. Do I have a minimum value anymore? What's the range for this one? Let's say this point here is 6, -1. Let's say that's the point. What's the range? Oh, Brenna, what's the range?
Y is
Yes. So is this the minimum? There's lots of y's that are smaller. So what is this really? It's the maximum. So a vertex, it's always a turning point. Sometimes it's a minimum, and sometimes it's a maximum. So these are all little words we're going to learn here. Cool stuff. You guys are doing great. New word here, concavity. I'm right in the middle of page 1. Concavity is not didn't brush your teeth, right? No. Concavity. Concave up. Thank you for that one laugh. Thank you. Concave up or concave down. When we talk about parabolas that are concave up or concave down, concave up, concave down. I like to think of this one as a smile.
and a frowny
And a
face.
frowny face, yes. So concavity. Parabola opens up or the parabola is down.
What about convex?
Convex is a different thing. So we're just talking about concavity when we're referring to this thing. So if I say I've got a concave up parabola, you should get this picture. If I say I have a concave down one, you should get that one. Now, when do I know it? When the A is positive. What A?
X squared plus BS equals.
When this is a positive number, you're going to smile because positive is smiling. And when it is a negative number, then it's negative because, you know, you're negative, you're not a happy person, you're frowning. All right? So if I have this equation, concave up, concave down. Up. The A, the thing in front of the x squared is a positive number. What about this one? Frowny face. So I know, I already like, so graphing, the idea is, just by looking at it, what can I tell? I know concave up, concave down. What does this say? All right, this will be a minimum. So if you look like this, you have a minimum. And if you look like this, you have a maximum. Makes sense? We kind of talked about that a little bit. I hope it does. Ask a question if it doesn't. Ask a question. Don't sit there. Be active instead of passive. Okay, graphing calculators. So you know our graphing calculators. I do want to use that quite a bit here. So if you got your graphing calculator, let's remind ourselves how this works, right? So y equals x squared. You press the y equal up here, right, top left. And this first one I'm going to put in x squared. And remember how to do, well, that's not it. Yeah, I pressed the wrong button. Next to your alphabet is where the x is, and over here looks like the square. And that's it, graph it. Press the graph button upper right. There's my parent function. Parent function, y equals x squared. We can build any parabola starting with this. Now I'm going to put y equals negative x squared right below it, so that it'll graph both of them. So what do we expect to happen? What do you think is going to happen?
A problem will.
It's going to be the same thing.
It's hourglass.
Now, I know this one is concave up, and I know this one is concave down. Basically, I performed a transformation. I flipped it. I made a reflection. Just by putting that negative in front, it was pretty cool. It is cool. So that's pretty neat. So again, that's what I mean by you can graph by just kind of looking at it. You can sort of get what it looks like. Dilation, we haven't really talked about that. When the absolute value of A is greater than 1. So, again, I'm starting with like a standard form. So what does that mean? It means that this A, 5 or 6 or 100, it's a big number. What happens? You get a skinny parabola. If it's less than 1, like a half x squared or something like that, it gets kind of wider. So we kind of call this thing a stretch. And this, what do we call this thing? A compression? So it's like I took like the vertex and the ends and I squeezed real tight. That's a stretch. It's narrower. Or I kind of press down on it and it gets kind of what is that? Quite an expression.
stretch it before.
You want to think that the 4 is somehow going to do, it makes it really skinny. But you know what, with lines it does too. Remember y equals x? Looks like this. Y equals 4x. That's also a dilation. Or remember y equals like 1/4 x? We did this. It got real flat. Oops. It got real flat. Same things happen with lines that happen with these. So let's just look at y equals 4x squared. I'm going to keep x squared there and just do 4x squared. Here's x squared. Look at 4x squared. Right? So now, if I want to put in 1/4 x, and watch how you do that, don't turn it into a decimal. Just make a parenthesis. 1 divided by 4, close the parenthesis, x squared. That's how you can, looks like, I keep hitting the wrong button. There it is. So we're going to see x squared, the parent function. We're going to see the skinny 4x squared, and then let's see what it is when we see how it gets started. No. Yes, Steve. Yes. Yes, it does. So make sure that fraction is in parentheses. So again, this is another transformation. So if the a is a big number, you get long and skinny. If it's a fractional piece like this, it's going to get shortcut. So again, by looking at it, we can kind of see what these numbers and values. What's going to happen if I put a negative in front of it?
It's gonna be what?
It's gonna flip.
It's gonna flip.
Flip the other way. So they're going to look just like this, but they'll be down here. So it gives us a sense of just by looking at the equation what they look like. It help us with graphing. Alrighty, transformation some more. Ooh, what about this? X squared plus a constant. So I'm taking my parent function and I'm adding a number. Boom. 10, right? So let's see what happens with those. So I'm going to go down up here. And I'm going to keep my x squared because that's my parent. I'm going to clear out the other one. So I want to see what happens if I add something. So I'm going to take x squared plus a number. What do you think is going to happen? What happened to the lines? Remember y equals x? That looks like this. What happened when we said y equals x plus 3? This is meant to go through the order here. What happened? Huh? Picked it up? What happened when we said y equals x minus 7? We took this one and put it down here. So what do you think is going to happen here? Oh, let's see. Here comes x squared. So what does x squared plus 3 do?
It makes it go up 3 or
And what kind of transformation is that? A
Slide.
slide? What's the other name for slide?
Translation.
Translation. This will translate the figure up 3. What do you think is going to happen here?
Translate the figure down 4.
Down 3. Oh, down 4. You guys just want just to prove it. There it goes. So again, looking at the different, just how it's written, helps us figure out what it's going to look like. So here's some of the conclusions here. This on the paper, because if it's not, we can write this down, right? So I don't see it, so maybe we should write this down. When C here is a positive number, what happens? The graph moves up or down. When C is a negative number, the graph moves down. It's up there. It's up there somewhere. Not here. We should write that down. Well, there's a little bullet here towards the bottom. See where it says transformations. It says f of x equals x squared plus c translate up, positive c, or down. I'm on page 1. Oh, yeah, it's there. It's on page 1. Yeah, see where there's the bullet that says transformations? Count the 4th sub-bullet. It's there. Yeah. Yeah, it's there if you want to maybe circle it or something just to kind of draw your attention to it. This is really helpful to kind of know just by looking. What is this thing kind of like? Even if you don't have a graphing calculator, get that sense in your head. Okay, awesome. What else do I have to say here? All right, how do you graph them? A couple of ways if you're not using the graphing calculator. Table of values. This is the exact same method that we did with lines. Make an xy table. Right? Suppose I have y equals x squared. Negative 2, negative 1, 0, 1, 2. Plug them in. If you plug in a negative 2 here, what do you get? Careful. What is, if I plug negative 2 in for x, what's y? 4, because it's negative 2 times negative 2. What about a negative 1? 1. What about 0? What about 1? Yes, ma'am.
Why are the Y values
Here, what you do is you take the x and you plug that in here, and then I did the computation. So over here I said y equals negative 2 squared. Negative 2 times negative 2 is 4. Yeah, so any xy table, and you can use this method for any function at all, right? If you come up with some x's, plug it into whatever the rule is, and you get some y's. That is one way to graph parabolas. Another way is to kind of use these things we just talked about to kind of discover a little bit about it. Is it concave up or down? Where are the zeros? This is what we practiced last unit. Where's the vertex, which I'll show you how to do. And then you try and sketch it. So this thing here, this, oh my goodness, this is an important day. I'm looking for it on your paper. On the back now. Okay. Where is it?
over here? It's vertex.
Okay. The axis of symmetry. Remember what that thing is. What is that again?
The line.
It's a line. Extremely important. And that's where if I fold a piece of paper on that line, it's the same on the left and the right, right, for my parabola? This is how you find it. What's B? What? What's B and A? What are we talking about? Huh?
Ax squared plus
Dx is C.
Yes. So it's talking about D's and A's. So if you have a function, y equals x squared plus 2x plus 3, what's the axis of symmetry? Well, let's see. What's A? 1. What's B? 2. And what's C? So x equals negative b over 2a. So negative, what's b's value? 2. And 2 times a, what's 2 times 1? So is the answer negative 1? X equals negative 1 because the axis of symmetry is a line. You tell me negative 1, I am telling you you're wrong. X equals a line. Alright? And then how do you find a vertex? Is this confusing to anybody?
Yes.
Can anybody interpret what this is saying? Because it looks like, what? What does that mean, Claire?
It means to find the
Okay, so what's happening here? What is negative b over 2a? Didn't we just see that?
it's the inverse.
The inverse. Whoa. Whoa. First of all, you see negative b over 2a, you see negative b over 2a. These are the same. This is a line x equals negative b over 2a. So for this graph right here, this is the axis of symmetry, right? Remember how that works. At the line x equals negative 1, the vertex will be there because that's my fault line. So if I want to find the vertex, what's its x value? Negative 1. It's always on the axis of symmetry. So whatever value you get here, that's the x value of the vertex. Say, okay, it's negative 1 in this example. How do I find its y value? Times it by f. What is f of x notation? What does f of x notation mean? This says f of negative 1. What does that mean?
X is negative
Y
1.
is
X is negative 1. You're going to plug a negative 1 here. Answer me this. If you know the x value, how do you find the y value?
just solve the Y.
Plug her in, right? So this is a fancy way of saying, once you know your axis of symmetry is negative 1, plug it in to get the y value, and that's your vertex. So for this one, negative 1, and I plug in negative 1. Oh boy, negative 1 times negative 1 is 1. Plus 2 times negative 1, that's negative 2. 1 minus 2 is negative 1. And I think it's 2.
What about the plus 3?
Oh, right? What?
What about the plus 3?
What about the plus 3? I want the vertex. I want this first. What is this plus 3?
So the y-intercept.
Y-intercept! How'd you know that? You're this
It's
guy.
y
Gold star.
Okay.
The y-intercept happens when x equals 0. What happens when x is 0? So that's a y-intercept. So see, we're like getting values already. We're getting values. So this idea here is, let's be a little smart. We may still need some table of value stuff, but let's be smart. And that's what we're going to be looking at. What does this say? The other way is the graphing calculator. I'll tell you right now, you're really going to use both of these together. It's going to help, one will help the other. Okay. All right. Quick example for the table of values method. Do I have one here? On the front. Okay. sure. Now, so I make an XY table, and I got this one on the bottom of page 1 there. So now you got to be real good here. You got to say, okay, if I'm doing -2, what am I doing right now? What did I just do? I took this x, and I plugged it in for x, right? Is that how you find y?
That's right.
Okay. 4 plus 6, I guess it's 11. Does this give anybody a headache? All right, who's got a little computer sitting with them? Anybody ever make a mistake doing stuff like this? My hand's up. Anybody? Anybody? No, just you and me? Okay, 4 of us have made a mistake. A lot of us never make a mistake doing this, okay? Come on, every single person makes a mistake. Get a calculator. One way to handle this is to say, why don't I use my calculator? So when you substitute in -2
Don't you ever mean y equals?
what? Well, it's understood y equals. I just want to evaluate this part of the expression because, you know, it's me and I make a lot of mistakes. Ooh, it did it. There's another way to do this. The other way is press your y equal button, and I'm going to clear out the junk I got here.
Oh wait, what?
All right. The one way, all right, you missed it. The one way is just substitute in, press enter. You might make a mistake.
11.
Press y equal. What does y equal? This. Put that in. All right. X squared. Everybody doing this? This is a really good thing for you to be doing with me.
I got it.
Hit that little finger right there. Check. Did I type it in right? X squared minus 3x plus 1?
Yes.
Did I do that right? Get that in there. Get it in there. Okay, now, don't press the graph button yet. Look above there. See that word table?
Yeah.
It's the same color as your second key, right?
Second.
Press second and table.
Oh, I did. Oh, it has a lot.
Oh, okay. -2 is 11. What's -1?
That's nice.
5.
Look how fast this goes.
Oh my
What's
gosh.
0?
0 is 0.
No, 0 is 1. 1 is
One.
-1. Negative. Wait a second. What's happening here? Look at these crazy values coming up.
Oh, it dipped below the.
What do you, without looking at your calculator, what do you think 3 is going to be?
Oh, it's gonna be.
I think it'll be 1.
Maybe
1. It's gonna be 1.
What do you think 4 is going to be?
No, I think 5. 3 is gonna be 1.
4 is going to be 5.
Yes. All right, so explain, Claire, and then Ryan has it too. Why?
Oh,
Why is it what's happening?
Because the intercept is 1 and the curve is
The y-intercept is 1, right? But look what's happening here.
Oh.
It's a parabola. It bounces back up. It's symmetric, right? I knew that without looking here. I got look. See,
I
look.
got 3 as 1.
Oh, we didn't do it. 3 is 1. Okay. We missed.
Aha,
I missed
I
this one.
told
That's
you.
why. I missed this one. We missed that guy. But you were right. So 5 would be the 11, right? Okay. So we can graph this now. -2. I think 11 is off the page a little bit.
But if it's -2 and -1 and then 0, 1 and 2, wouldn't 1 and 2 be -5 and -5? Or -5.
Well, it's basically I'm taking advantage of the symmetry. So once I kind of know one side and I start seeing it turning, it's all going to turn the other way. So this is table of values. Now I don't really know how much it dips, so I basically guess. That's table of values. I can get an idea of what it looks like. And of course with this I can say, gee, that looks good. That's pretty good. All right, so this is your check that you got it. Okay. So the pros of this method are it's easy. We know how. Look how easy that was. The cons, sometimes it's hard to find the inputs that will give you this nice little shape. What if you had something that was like all the way, around the other way? Sometimes, how do I know how far down this goes? So it's good for some things, but we want to get some more exact things. So x squared minus 6x plus 5. Now we're on the back. So we're going to use that kind of second method. We're going to be a little bit smarter rather than just a table of values. So here is this thing. The first thing you want to do, what's A, what's B, and what's C? Let's just look at this and analyze that. What's A in x squared minus 6x plus 5?
1.
What's B?
-6 and 5.
Now let's see. Is this concave up or down? Oop, how do I know? A is a positive number. So I know it's a smile. You might want to even make that little picture just to remind yourself. That's going to be a smile then. What's the y-intercept?
5.
And it says the y-intercept is always c. Why is the y-intercept always c? Huh? Because why? A y-intercept, what value is 0, x or y? X. If you plug 0 in for x, you get c. Well, we get to the vertex. So graph that. Right? You have a y-intercept. Here it is. Graph it. Okay, now here comes the fun part. Axis of symmetry. Remind yourself what that is. And I want you to make this conscious think. Stay with me. Some of you are racing ahead, but I want you to stay with me because a very common mistake is right here. So I don't want us making it. This is a line. Can this answer be a number?
No.
No. What's it going to look like? X equals. It's a vertical line. It's going to be an x equal. Now I have a formula for it. Negative b over 2a. So let's see. Negative, what's b's value? Negative 6. So it's negative 6 over 2a. What's 2a? 2 times 1?
2.
So negative, positive 6. So the axis of symmetry, x equals 3. You tell me 3. That's wrong, it's not 3. It's x equals 3. And here's what you do with that. So that's our vertical line, right? Negative 6? Yeah, that's positive 6 over 2. So x equals 3 is a vertical line. Now I'm going to graph it, but I'm using dashed lines here. Why am I using dashed lines to graph x equals 3?
Not an actual line.
It's not really part of this graph. It's like a guideline. It's going to help me. Because, yeah, well, look at this. Because I know when I fold on this, it's going to be a match on the other. This point here is going to be on the other side. So what I can do is say, well, let's see, that's 1, 2, 3 away from the axis of symmetry. So 1, 2, 3 away. So a point. So having the axis of symmetry kind of helps me see, okay. All right. Okay. Now, vertex lives where? On the axis of symmetry. Remember, that's my fold line. That's where the turning point will be, the vertex, which is the turning point. Am I going to have a maximum or minimum? It will be a minimum. My vertex will be a minimum. It's always nice to know. So let's see here. What is it? It's an x right there. What's the x value?
3.
3. Why is it 3?
The axis of symmetry is.
It's going to be on this line here. What is the x value of any point on this line? X is 3. Okay. I know an x. How do I find a y?
Plug it into the.
So I get 3 squared 9. 9 minus 6 times 3. 9 minus 18. That's negative 9. Plus 5. Anybody have trouble doing that kind of thinking?
Yeah.
No? If you don't, fantastic. If you do, you've got a couple of choices here. You can go and just plug it in with a calculator. So 3, and I'm using this one. 3 squared minus 6 times 3 plus 5. What am I doing here? Is anybody like?
I'm plugging in the
I'm plugging the 3 in here so that I don't make a math mistake. Here's to be negative 4. The other way is to go to y equal, clear out what you got there, and type in x squared minus 6x plus 5. So x squared minus 6x plus 5. Did I make a mistake? I plugged the 3 in 9. I plugged in the 3 here. And I had the calculator do it. But let's check another way. So I put it in here. How can I check another way? Where do I go now? Table. Yeah. So press the second button and the graph button. And let's look for where x is 3. Okay, it's negative 4. So I didn't make a mistake there. So if you're likely to make a mistake, and I know I am, I like to just make sure I did it right. The calculator can help me. So 1, 2, 3.
Wait, so how do you go to
Plug it in. You just say, what's 3 squared minus 6 times 3 plus 5? And I just have the calculator help me out here. That's 9 minus 18 plus 5, which is negative 9 plus 5, which is negative 4, right? So we can get there. But sometimes if we make a mistake, and when you're taking the SOL exam, we don't have a lot of time. I like to save our brain power wherever we can.
So do you have a lot of that?
No. So I had a lot of questions. So I like wherever we can save brain power, save it. That's why I'm kind of showing you these other ways. Yes.
Really?
Yes.
Wait, that's almost time?
No, on the graph.
Oh, this one. Okay. Axis of symmetry, right? was the y-intercept. So it's 3 away. So 3 away on the other side is going to match.
You had the final symmetry before you actually found the
This one? X is, I did x equals negative b over 2a. So x equals 3. That's how I got that. And I sketched it in, and now I know. So 3, negative 4. Look at this. Does it start with a smile?
Yeah.
The other guidelines I want is where are the zeros?
I got it.
Oh, thank goodness. We learned this. How do you do
I
this?
said x versus 0 and true like happening.
Look at this guy. Right? Remember we said how you find the zero? Set the function equal to 0. Okay. Well, how do I factor this guy? Type 1? No. Type 3. X and X, right? I need two numbers that multiply to 5, but adds to negative 6. Oh, let's see. Ben, what is it?
6.
Negative 5 and negative 1.
6 and negative 1?
Yeah.
Oh, when I multiply, that's not it. Oh, wait a minute. This one?
No.
Yes, that works, right? Multiply or add down. So what are the solutions to this equation? What did I just find here? What are the zeros? What does that mean? I'm going to just put it in numerical order. It doesn't really matter. But what did I just find? Which are what? X-intercepts. So over here at 1, and at 1, 2, 3, 4, 5. And then this is called sketching. So I'm going to kind of connect the dots that I know. See these arrows? They're important, right? They're all real numbers can look like that.
How many 46 times 41
Good question. It depends. So like this, I can kind of see it. Sometimes when your line is like here, if this is your vertex, you don't get much else because that's your 0. That's everything. When this happens, make a table and just find a few more points. If you feel you don't have enough points, you can always use the table of value method to get a few other points. What do you think? Calculator. Checking our work here. So y equals this. I'm going to graph it first of all. Does it look good? Yeah. All right, now how do I check that I have the right zeros and the right vertex? This is important. Everybody's going to do this with me. Very important. The calculator will tell you what the zeros are and what the vertex is, so you can check your work. So let's say, what do you want to start with, zeros or vertex? Zeros, let's start with zeros. Making that decision. All right, where are they? Here and here, right?
So 1 and
Okay, now you can try and count. Sometimes they're not nice integers. You can't really tell what they are, or sometimes they're really hard to see. Look above the trace button. Do you see your word count? Everybody see that? Everybody's doing this with me. So you press the second button to get to the count. I want to find zeros. What should I press now? 2. All right, you see this? I call it a spider because it's like a spider. It's blinking, right? A little blinking cursor. It says left bound. All right, I'm looking just 1 0 at a time. 1 0 at a time. So I'm going to work on this one. This little right arrow key. I move it till it's just before. Don't touch it. Just before. Left bound, I'm going to dig. That's my left bound. Then it says, what's your right bound? Go down. You're going to go a little bit to the right of the 0. Bound it to the right. The calculator knows it's somewhere in between. Then it says guess. I'm like, oh. So you press it. It's thinking, oh, 1 0. Is that what we think? Okay, good. Okay. Now let's see what the other 0 is. Do it again. Second in the trace button. Calculate menu. Press 0 again, number 2. Now I'm working with this one. When I want the left bound for this, I have to kind of get my little spider over there. Okay, see how it's a little bit to the left of that 0? Press enter. When it says right bound, I'm like, okay. I'm going to move a little bit to the right. When it says yes, say I don't want to, you tell me, so press enter. Here's the other one. Did I find the right zeros? Now, okay, questions on that. This is a really handy little thing. Did you do it with me? No. See, you got to do it with me. Cursor. What it's doing is it's doing some mathematical analysis on finding what that value is. You don't care how it does it. But you have to tell it it's bounded by these 2 values, and then it does some magic and it figures out what it is. All right? This is an important thing to know how to do. Trust me. If you want to make it out of that SOL alive, you need to know how to do this. Now, what about the vertex? That's here. How am I going to find that value?
You do the same
I do, but is that a zero? Not a zero. Yeah? Yeah, and I wish there's a button. Is there a button here called vertex? I'm looking again. I just pressed the calc thing again. Do you see vertex anywhere? No. Minimum or maximum, those are another names for vertex. So you need to know something about this. Does this have a minimum or a maximum? Minimum. Because think about this. Now I'm pressing number 3, minimum. Look at this thing, right? Does it go any lower? Nope, that's the minimum value. And then it's kind of the same. Left bound or what? Of your minimum value. So I'm going a little bit to the left of this vertex. When it says right bound. Okay, then it says right bound. Go a little bit to the right. When it says yes, just press enter. Now, sometimes it's got a little algorithm. It's not perfect. What number is that? Really? 3. 3? Did I find the right vertex?
Yeah.
3 and -4. So this is a really handy thing to check your work. Should you ever have the wrong vertex or zeros on any of these? No. Check them with this calculator. Check them. And when you're taking the SOL, use these shortcuts to get through that test. 50 questions plus some extras. A lot of stuff. I don't want your head to this work. 50 plus the test questions. So, alrighty. So let's do a couple of other examples.
Oh, no.
Yeah, just a few more. So let's see. You start with what's A, what's B, what's C, what's A?
-1.
What's B?
6.
And C. Concave up or down?
Down.
So this is my little frowny. Little frown. What's the y-intercept? -8. It's always this value C because x is 0. So let's graph it. 2, 3, 4, 5, 6, 7, 8. I think that's the right one. Sometimes I've been missing. That. Okay, I'm looking for that axis line. If it helps you remember line of symmetry. So it's going to be an x equals because it's a vertical line. And it's negative b over 2a, right? So negative, what's b's value? 6. 2a is what? Negative 2. So what is that?
X equals 3.
3. X equals 3. Not always x equals 3, these two examples it was. So I'm going to put a little dotted line there. Y'all doing this with me?
Yeah.
Question?
Is axis of symmetry formula always negative 3 or?
Yes. Okay. What can I do now that I know the axis of symmetry and I have a point here? What can I do? Well, I didn't have to plug it in yet. I just want to get another point for free. Yeah? Yeah, put the reflection on the other side. It's like a 3 point. So if I'm 3 away from this, I'll be 3 away on this side. 3 point, just like that. Now you're right, vertex. What's the x value of the vertex? 3. You're going to plug 3 in to find the y value. So an easy way, so we're not like here forever, right? I'm going to put in this thing here. Now be careful, negatives are not a minus sign, it's its own negative. So negative x squared plus 6x minus 8. And let's look at the table. Right, I'm looking at the table for value 3. What is it? 1? Negative x squared plus 3, 1. So 1, 2, 3, 1. Is it starting to take shape here? Do you see what's happening?
Yeah.
How many zeros will this thing have? How many?
Oh, 2.
I heard none, I heard 1, I heard 2. Tell me why. Yeah, I think what's happening is going to pass here, there's 1. Going to come back down, there's 2. It will hit here 2 times. Let's see what they are. So I have to set the function equal to 0. Now when there's a negative up front, what's the smart thing to do with 0, which a lot of people did not do on the test, by the way? Factor out the negative. And then what happens? All of the signs flip, but the most important sign that flips is this one. So you keep your negative, but I'm going to factor what's left. So this is a type 3. There's an x times an x to get my x squared. 2 numbers that multiply to 8, but add to negative 6. Negative 2 and negative 4. X squared. I'm doing this multiplication back in my head to make sure I'm there. So what's the x x values?
-2 and -4.
When does x minus 2 equal 0? When x is 2. When does x minus 4 equal 0? So 2 and 4. So that's here. There's 2, 3, 4. And they should also be symmetric, right? If you're doing it right, they're going to be symmetrical around there. And there it is. And again, you can use the calculator to help you verify. So let's do that. See if we can do that quickly. Now if I graph it, it looks good. Let me check my zeros. So if I press the calc button, if you didn't do this before, do it now. So press the second button in that trace key, go to your calc. Then you say, I want the zeros, so number 2. I'm going to do this 0 first. You have to do them one at a time. I want to be a little to the left of it, press enter. Then I want to be a little to the right of it, press enter. And it says yes. So 2. Okay, that looks good. I can do it one more time. Second trace button for calc. The other 0, press 0 again. You get real fast with this. So we're a little to the left of that one. Keep going. A little to the right of that one. Press enter. 4. Excellent.
What happened?
How do I check the vertex? Is this a maximum or minimum?
Minimum.
Maximum.
Maximum.
Can I get any bigger than that?
No.
So when I check my vertex, second trace, maximum, number 4. All right, and I left down, I'm going to go a little to the left of the vertex, and I'm going to go a little to the right of the vertex, and then I'm going to press enter. All right, boom. I get 31. Yay! Don't we feel better? Do we make it? I'm feeling good. Use this thing. Use this thing. It really is a lifesaver. This can be really hard because of all the little calculations. So very often the vertex is negative b over 2. You get a fraction a lot. Oh, right? So plugging in a fraction is kind of hard. So let the calculator do some of that work for you. Look at this guy. Now, before we do anything, remember our parent function stuff? What kind of transformations happen here? Y equals x. What's happening to y equals x squared? Our parent function is y equals x squared, right? That's this one. Sliding down one. It's going to look like this, isn't it? So we kind of already know what it's going to look like. Sort of, right?
Yeah.
Translates it down. But what's A?
One.
What's B?
B is 0.
0! The B is the thing in front of the x, right? I don't see an x. What's C? Whoa. Concave up or down? Smile. Right? Y-intercept. Axis of symmetry or line of symmetry. How do I find it? X equals negative b over 2a. Negative 0 over anything is 0. X equals 0. So it's just the y-axis, right? I'm trying to make my line here. Isn't that x equals 0?
Yeah.
Okay. What's it? And then my y-intercept, I forgot to do that one. It's here, right? Now this one, because I'm on here, there's nothing, no 3-point. Vertex. What's the value, x value of the vertex? 0. Right, plug in. This one is easy to plug in. What's my y value? Which I know, here I am. I saw it already. So this is one of those, I don't have a lot of clues here. What about zeros? When does x squared minus 1 equal 0? What type is this?
Type 2.
Type 2, which is like sum or difference, right? What's the square root of x squared? Square root of 1 plus minus. So what are the zeros? 1, 1. Okay, and there goes here, and there goes, and it's a smile, right? Something. This is a case where you might want to have a couple more points. Just as, what happens at like x equals 2? Now you can plug that in. 2 squared is 4 minus 1 is 3. And it's symmetric, right? So I'll have another one. So just by getting like one more point, I get a little more guidance. And does it match what we thought it would? Is this a parent function? Translated down one? Yes, it is. Think about transformation. So it really does help if you have that knowledge ahead of time. All right, we're getting there. Almost there. So let's look at this guy here. Let's do A equals B equals C equals. What's A?
A is 1.
B?
Zero.
Zero.
C?
Two.
Okay, up or down?
Up.
Look at this, what do you think it's gonna look like? Transformations, think about it. It's the parent function translated up to. So it's gonna be like, one of these. All right, what's the y-intercept? Put that here. Axis of symmetry, the line of
Zero.
symmetry.
Zero.
Once again, b is 0, so negative b over 2a is this thing. And it's doing what we expect it to do, right? What's the vertex? Right, the x is 0 goes here. Oh, I know that, here it is. And it's doing this. Look at this, zeros. Oh my goodness. First of all, you know, you do this, maybe you're on autopilot. But now let's think for a minute. X squared plus 2. I know this is the vertex, and I know it's concave up. Looking at the picture, how many zeros? There won't be any. And let's look at the math here. Let's try this. I'm going to subtract 2. So what squared gives me negative 2? Yeah, right? Because when you square a number, it's always positive. When it gets all wacky, right? None, because I'm going up. This is another case. You know what? 1 point's not enough. Let's see what happens at 1. Let's see what happens at 2. If you plug a 1 in, what do you get? And again, if you're like, I don't know, you can use the table on this as well. And again, symmetry of 2 squared.
6.
4 plus 2. 6 over 2. There's going to be a match on the other side. And yes, you can use this with the table. If you're having trouble with just, it's too much work, go in here, put in the function, x squared plus 2, go second table, right? And then here they are. Right, 1 is 3, okay, I did it right. 2 is 6, right? And now I can see enough to kind of, and does it look like this parent function?
Yes.
It does. Transformation. So all these little things help us to graph it. So dare I say it, I'll be ready to use the calculator. Let's do another example. Is this the same one we did? I'm trying to think if we did this one already. No. Yes, this was example A. But using the calculator. All right, concavity you know just by looking at it. This, the y-intercept you know. Vertex, use the calculator. So, I mean, look how fast it can go if you do. And for my tests, you're using it as a check. When you're working on the SOL, just do this because I don't want you sitting on a function for 10 hours. So you put it in, you graph it, you say, gee, does it have a maximum or a minimum? Maximum. So I press here, I go number 4, maximum. I zero it a little bit, I go to the left of it, I go to the right of it, I press enter. There it is, 3, 1. Look at that. Find the zeros again. Does anybody need to see me find the zeros again? No. But this is a check all your answers that way. Especially if you get sometimes there's a symmetry. It's hard. Use the table. All right. I've got some new tries here. Give them a try. Do it, manual way, but verify with the calculator. Now let's talk a little bit here. Concave up or down? What's the y-intercept? Graphic. Axis of symmetry. X equals negative b over 2a equals negative 1 over 2 times 1. It's 1/2. Really? Whoa, isn't it?
Yeah.
Okay, so now what happens? I gotta make this little line, right? Oh, look at that. 1/2. You couldn't, change the scale if you wanted to. So, okay, this one's going to be on the other side of it. Oh, look what's happening here. Now, the vertex, what's the x value of your vertex? And now I got to plug that in here? Okay, here it goes. Right? I'm like, nah, that's it. I cry an uncle. So, you know what that means, right? Give it up. So, I'm going to put this in. I'm not really giving up. I'm just going to do it in a way that won't be crazy. So, minus x minus 2. Check. This is one of those things. Make sure you type this in right. Now, when I go to my table here, I don't see a half. Remember how you can change this? We talked about this once. Table set button. See it up here? Press the second. It's like the second button over where it says table set. this delta table, I'm skipping by ones, change it to skip by halves. When you go back into the table and press and graph the table, what is it at a half?
Negative
So at 1/2, I am at -1, 2, a little bit past that. Now this is a concave up. Do you see what's happening here now? How many zeros will there be? Two of them. So let's see if I can figure out what they are. Right? Set the function equal to 0. That's an x. Alright, two numbers that multiply to -2 but add to -1.
Negative 2 1.
So what are my x's? 2 and -1. So let's see, there's a -1 and one over here. Isn't it?
I did that on calculator.
Where did we get confused? What? And then, wait, tell me where you're confused. I don't want you to be confused. The other way to kind of know is I don't want to say choose, but you can look at this, graph it. And then, I guess that's right. And then you can use, is this a maximum or a minimum? Minimum. So I can find it. Let's see if I did it right. Minimum. Close to the left or close to the right? Yeah, that's it. 0.5, you got it. You can do it to find the zeros as well. Then you go to the same thing. Calc and press number 2 zeros. Go to the left and right of each of those zeros. Alright, we're running out of time, my friends. You may need to watch this video back and forth a little bit. You don't need to watch the whole thing. Take some of the examples, watch it again.